numbers that you need.
It's today, huh?
It is.
How have people been doing on the quiz today?
I haven't had anyone take it today.
Really? You're the first one?
You're my only pre-calc class on B-days.
What about like
Does
last?
that mean we're your best, Mr. Johnson?
That does mean you're the best. Also the worst.
Yeah, that's crazy. That's wild. No, but what about the 8A classes?
They were fine.
Fine. Like, how fine?
I'm not sure what difference it makes at this point. All right, before we start our quiz, I want to give one last chance to still get full credit on the assignments I asked you to turn in the Google Classroom. All of those are listed under the Bell work, 23, 24, 26, and 28. 23 was 4.5 notes. 24 was the graphs to equations worksheet. 26 was the 4.6 bookwork, and 28 was the 2 practice quizzes. So any of those that you forgot to turn into Google Classroom or just couldn't get into Google Classroom, wasn't working or whatever, again, you can still turn those in for late credit before we get to our second test, but this is your last chance to get full credit on those. So if that matches you, make sure your name's on them and come put them in the basket, please. After that, I need your phones and smartwatches put away. And our quiz is no calculator.
Mason said he's gonna be late today. He's gonna get here.
Okay, well. quizzes we gave you. Yeah, man. We'll just put the hard copies in the basket at this point. Take that page down so your stuff's put away. If you turn it in Google Classroom, you don't have to turn it in.
I haven't found it, but that's
Then you need to put it in the basket before you start. I think that's everybody. You let me know if I missed you. Notice that you put your name on it and number it as number 29. I would expect this to take you roughly 30 to 50 minutes. So if you're on the shorter side of that, you should consider trying to check some of your work, how we discussed last time. Each question has the point values on there, totals up to 25. And once all the quizzes are in, we'll go over those handouts that you guys picked up on the way in. Quiz. And if you didn't turn in the assignments in the Google Classroom, you need to put them in the box before you start.
The practice quiz.
Everything that was asked for in Google Classroom. It's also on the board. Okay?
selling that sweatshirt for city council. I
asked Coach 5 to email you.
Okay.
Not sure if she did yet, but
She is not.
are we taking the quiz right now?
We are. Did you get your assignments turned in Google
Yes, sir, I
Classroom?
did.
Okay.
Thank you.
Sorry, that's the wrong form for you. This is no calculator.
Thank you.
Yep. This. Either one. It's fine.
Coffee.
Mm-hmm.
That coffee I smell it. Do you make your own?
Mm-hmm.
Nice.
Thank you. I think we've got all of our quizzes in. So let's go ahead and look at the 3 handouts you guys picked up. These 3 handouts will make up our work for section 4.6. So at first glance, it may look like a lot between those 3 handouts, but it's actually a duplicate for what I'm about to show you on number 30. And then 31 and 32 is the exact same stuff, but it gives you a chance to practice. So in section 4.6, we don't do any book work. This is probably the most straightforward section we do all semester. I really think that this should be the easiest quiz we have this semester. Because even in, if you didn't know any trig, you could still, in theory, just memorize the stuff that you need to know from this section and still be able to get 100. So what we expect out of you in section 4.6 is you'll need to learn how to graph tangent, cotangent, secant, and cosecant. So 2 of those look the same, and the other 2 look the same, and I will tell you a trick to help you remember which one is which and how to make it look correct. And then for all 6 trig functions, we will ask you certain characteristic questions, but only the ones that we have listed here. So where are the asymptotes if it has any? What's its domain and range? Is this an even function or an odd function? What type of symmetry does it have? What's its period? And is it continuous or discontinuous? So we're going to ask the same questions about all 6 trig functions. Yes?
What number is this in terms of binder?
The notes is 30.
Notes is 30.
The one that has 4 graphs on it is 31. And the one that's a big chart is 32.
Alright.
Okay, so starting on the front page, starting with sine and cosine, because we are more familiar with those. And again, partly what makes 4.6 easy, or easier, is that there's no transformation changes. So in 4.6, you don't have to worry about amplitude or vertical shifts or phase shifts, just the parent functions and being able to answer those questions about the parent functions. So at this point, I hope that you know what sine looks like and cosine. But if you forget in a couple months, and the way that I'm going to help you graph the 4 new graphs is remember that you can always use unit circle to get a couple points. You can think about the sine at 0 is 0, which means it has to go through the point 0, 0. The sine at pi over 2 is 1, which means it has to go through pi over 2, 1. The sine at pi is back to 0. The sine at 3 pi over 2 is -1, etc. You can do as many points as you need to. And of course, the more comfortable you are with unit circle, the faster you can spit out some different points. And then we did the same thing for cosine, plugged in a couple points, just the easiest unit circle points I could think of. I know the cosine at 0 is 1, so that means it goes through 0, 1. The cosine at pi over 2 is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. So again, I don't think this is necessary for sine and cosine, but you will still need to do this for tangent, cotangent, secant, and cosecant in a minute. So still good to talk about it. Okay, now that we've got sine, Jack, you need to take your name off the board. Now that we've got sine and cosine graphed above, we can talk about if it has any asymptotes. So asymptote looks like this. A vertical asymptote is when you have this vertical spike in the graph. Sine and cosine, neither of these have any asymptotes, so none for that. This is what an asymptote looks like. Domain just like in algebra, it's asking you to describe the possible x values that you can plug in. And if you look at your graph here, this guy goes forever to the left, forever to the right, and it hits all of these values. So everything as far left as negative infinity, and everything as far right as positive infinity. Now for domain and range, parentheses and brackets are important. Putting a bracket where there's supposed to be a parentheses is wrong, and putting a parentheses where there's supposed to be a bracket is wrong. Infinity and negative infinity both need parentheses because you can't ever reach those numbers. Okay, do you see that the domain of cosine would also be negative infinity to positive infinity? You okay with that? Okay. So domain is a way to describe the x values, the defined x values of the function. Okay, range is a way to describe the y values. So both of these go down as low as -1 and as high up as +1. But because it actually has a y value of -1 and +1, you have to use brackets instead of parentheses. You need to include those because it actually reaches those values. But range is a description of the y values that occur from the function. Okay, these two basically go together. I can look at the cosine graph and see that it is symmetric to the y-axis. Flipping it over the y-axis produces the same graph, and that's a characteristic of an even function. So if you don't have them memorized which ones are even and odd anymore, that's a way that you can figure that out. Graphs with symmetry to the y-axis are always even functions. And even functions always have that type of symmetry. They go hand in hand. Whereas the others were odd, and so their type of symmetry was respect to the origin. That's a fancy way to say 180-degree rotation. So I can't do this with my paper, but if you took a mental snapshot of what the sine graph looks like, turn your paper upside down, it still looks the same. That's 180-degree rotation. That's what we call symmetry to the origin. Any type of graph that has that type of origin tells us it's an odd function. That's a characteristic of being odd. Okay, we can look at our graphs and measure period. We have to look at 2 pi of space to see one full cycle and 2 pi of space to see one full cycle. Again, we're not doing any transformation changes in this section. You don't have to worry about the 2 pi over b in this section. And then finally, continuous versus discontinuous. Continuous is where the graphs are nice, smooth graphs with no sudden breaks in them. What would make a graph discontinuous is if it had holes in the graph or asymptotes in the graph. Those would be breaks that makes it discontinuous. Being continuous or not continuous, it's not too big of a deal in pre-cal, but if you were going on to calculus next year, being continuous is a very big part of calculus. So, okay. So one thing, I know you guys are familiar with sine and cosine, but what about these questions? Any of these you want me to repeat how I found again? Because I'm going to ask you to do the same thing with the next graphs.
Can you go over how you determine whether or not it's even or odd and the type of symmetry?
Sure. So if it has y-axis symmetry, so if you could take half your graph, flip it over the y-axis and get the other half of the graph, that's y-axis symmetry, which is a characteristic of even functions. So you can just straight up memorize that there's 2 even functions, cosine and his reciprocal, and then you wouldn't have to think about the symmetry because those always go together. And if it's symmetric to the origin, so if you can turn your paper upside down and the graph still looks the same, that's a characteristic of an odd function. So I can't flip my paper around, but also if you just memorize that cosine and his reciprocal are the 2 even ones, then you know the other 4 are odd. So okay, so let's move on to the next page then, tangent and cotangent. So I need you to see how to graph these, and then we'll try to answer the same thing about each of these. The most important part is getting the graph down right, because honestly, once you know the graph, if you know what these questions are asking, you should be able to get the information out of the graph. You shouldn't need to memorize any of those characteristics. You should be able to figure it out from the graph. Okay, so we've kind of briefly talked about this, but notice how sine and cosine, just at a quick glance, basically look the same. They're the same type of shape. They're not the exact same graph. They don't start off at the exact same point, but overall the general shape of the graph looks similar. Well, that's true for tangent and cotangent as well. Both of these graphs are going to look pretty similar in shape, but they're not going to be at the exact places at the exact same times. So we have to, even if I told you what they look like, we have to pare down a couple of specific points. So that would be where I would highly recommend, even if you don't plug in a lot of points, plug in a couple of points. Think of tangent as sine over cosine and try to plug in something easy like 0. At 0, sine is 0, cosine is 1, and that gives us 0. Pi over 4 is an easy one. What's the tangent at pi over 4?
1.
It is 1, because sine and cosine are both the same thing. Square root of 2 over 2 and square root of 2 over 2. And you could do more points, but honestly this is probably enough after I tell you what the graph looks like. So more points is always going to make you feel more confident about your graph, but the tangent graph looks like this. Connects those and connects this. That is what one cycle of tangent looks like. And once you know what one cycle looks like, you can repeat that a couple of times until your graph is completed. Now, I sometimes forget this, but this is important in mathematics, that it's kind of understood that you should graph asymptotes as dashed lines. So let's add that to our graph. Now this is not a mathematical description, but I always remember tangent is, I describe it as snaking up. This guy's just snakes up. Now to know exactly where it starts and stuff, plug in a couple points in the unit circle and then just know the general shape. Cotangent is going to look very similar, but it's not going to the exact same points. So we can plug in maybe 0. Think of cotangent as cosine over sine. So the cosine at 0 over the sine at 0 gives me 1 divided by 0, which is undefined. What does that look like on a graph when you try to divide by 0?
Undefined.
What does it look like on a graph? Okay, that's how you get
Whole.
vertical asymptote when you try to divide by 0. So that's what's going to make it spike. Okay, we could try pi over 4, because if I know the tangent of pi over 4 is 1, then the cotangent is also 1. Reciprocal of 1 is still 1. You could try pi over 2. You can try whatever you want. At pi over 2 you get 0 over 1, which is 0. And for me, that's enough points, because I know generally what this graph looks like. So there's one cycle of cotangent. And then just repeat it a few times till your graph is full. Make each asymptote dashed lines. So, similar to sine and cosine graphs, just at a quick glance, these two graphs look similar. They have the same sort of shape to them. But again, they're not the same points. One goes to the origin, one doesn't. One snakes up, one snakes down. In theory, you can memorize tangent and memorize cotangent, and you will be perfectly fine for this class. But I will warn you that some years, some students just try to memorize and they try to skip plugging in a couple points, and they mix these two up, and then they miss a lot of points because they're answering opposite of what they should be doing. So, okay, before we talk about the characteristics, any questions about the graphs? Okay, so know they look the same, have a general idea of what they look like, and then plug in a couple of points so that you're sure which one is which. Okay, for the asymptotes, this is probably the one that's going to take the most amount of thought here. This guy has a lot of asymptotes. He's got one of them right here at pi over 2. So when x is pi over 2, there's one. But there's another one here, and my graph keeps going forever. So there's another one, and another one, and another one, but also go in the other direction. There's another one, and another one, and another one. So there's an infinite number of asymptotes. So we can't just begin to list them all out. We can't do that. We've got to come up with a formula that represents all of them. So to do that, just state the first asymptote, pi over 2, and then how much would I have to add to get to this one? Good. If I add pi, I get this one. If I add 2 pi, I would get the one that's slightly off the graph. I could subtract a pi to get this one, subtract 2 pi to get this one. So the others are integer multiples of pi away. So we say plus n pi, where n is an integer. This little symbol here is just it's a math symbol for element of, which is just a fancy way to say it's an integer. Okay, we can do the same thing over here. What would you call the first asymptote for cotangent? Okay, so let's start off at 0. And then how far apart are the other asymptotes? Integer multiples of pi. 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi, negative 3 pi. The only thing about this one is adding 0 doesn't really do anything, so we write it like this. But just list the first asymptote plus integer multiples of pi, because that's how far apart the other ones are. And
Wait, I'm going to say n. Can it be like 1 or 2 or 3? Or it would be 1 n pi, 2 n pi, or how does that work?
well, we have to state that n is an integer. So n could be any integer number. Negative 2, negative 1, 0, 1, 2.
Gotcha.
Anything that's not a fraction, basically. Now, this part can be confusing if you don't pay attention real quick, because my work is basically done for domain, but the answer is the exact opposite of what we just did for asymptotes. For location of asymptotes, we have to list where they are. They are when x equals this plus this, x equals this plus this. Domain is asking what x values can you plug in. Well, I could plug in most of this stuff. Most of this graph has an x value to it. In fact, I can plug in anything as long as x is not at an asymptote. And same with this graph. I can graph any x value that I want to as long as x is not at an asymptote. Those x values don't exist because they're undefined, and that's what's creating the asymptote. So these two, basically the same work, but they're saying the exact opposite thing. Asymptote is where it is. Domain, you should be excluding those because you can't plug in those x values. Okay, looking at your graph, what would you say the range of these graphs are?
Infinity to positive. Negative infinity to positive.
Good, they hit all the y values, so that makes it easy range. Me personally, I memorized that these are odd functions, and odd functions are always symmetric to the origin. You could test that by rotating this 180 degrees, rotate this 180 degrees. Same thing as turning your paper upside down. When you turn your paper upside down, this still looks the same. When you turn your paper upside down, this still looks the same. That is what we call symmetry with respect to the origin. which is always a characteristic of an odd function. So those two go together. If you know it's odd, you know the symmetry. If you know the symmetry is with respect to the origin, you know it's odd. Okay, what about continuous versus discontinuous? What do you think?
Discontinuous.
Okay, there's asymptotes all over the place. To be continuous, there needs to be no breaks in the graph. A nice, smooth graph. And then period. We don't have a formula for this like we did in section 4.5. But we can go up here and measure the period. This is one full cycle. And how much horizontal space is that? Very good. This is pi. And then this is one full cycle. And how much horizontal distance is that?
Pi.
Pi. So tangent and cotangent both have a period of pi. Again, you shouldn't be memorizing that, or I hope that that's the approach you're not taking. You should know how to read period from a graph, and once you practice graphing tangent and cotangent, you can just get it from the graph as you need it. Okay, and then the very last part of 4.6 is secant and cosecant, and then same questions. Just like sine and cosine graphs basically look the same, just like tangent and cotangent graphs basically look the same, secant and cosecant graphs are going to basically look the same. So once you know what they look like, you really just need to hammer down a couple of points. So if we think of secant as 1 over cosine and cosecant as 1 over sine, I'm going to just plug in a couple unit circle points. Like when x is 0, I get 1 over the sine of 0, which is 1. If I try to plug in 0 over here, I get 1 over the sine of 0, which is 0, which is undefined. Trying to divide by 0 creates a vertical asymptote. I could also try pi. Actually, let's not do pi. Let's try pi over 2. So cosine at pi over 2 is 0. So secant would be undefined. That would be an asymptote. But pi over 2 for cosecant would be 1 over the sine at pi over 2, which is 1. 1 over 1 gives you 1. So there's a point for that graph too. So it's not important what points I'm picking. I'm just trying to pick stuff that I can do quickly in my head for unit circle. But this is more than enough information once I show you what the graphs look like. Again, you only need a couple points to make sure that you don't mix these two up. Okay, so now I will tell you what these graphs look like. Secant and cosecant both look like parabolas alternating between opening up and opening down. When you have a point above the x-axis, that's when the parabola opens up. Same over here. And then after you have a parabola opening up, there will be one down here where the parabola opens down. And that makes up one cycle of each of these. Parabola up followed by parabola down. So then the next one would be parabola up. The one before it would be parabola opening down. The one before that would be parabola opening up. Lots of asymptotes. Same pattern over here. Before the parabola opens up, the parabola has to open down. Before it opens down, it has to open up. So again, almost the same graph, similar shape, but they're not the exact same thing. One of them is symmetrical to the y-axis, one of them is not. So make sure you plug in a couple points to keep those straight. Okay, so now for the location of the asymptotes. So the first part of this is going to be x equals, And what do you think the first part of the asymptote thing is going to be for secant? One more time. Okay, where is the first one? Okay, pi over 2. Just list where you see the first one at. And then the others are integer multiples of pi apart again. Over here, list the first one. Set 0. And then realize that all the others are integer multiples of pi apart. Adding 0 doesn't change anything, so we don't need to put that. Okay, so that's where the asymptotes are. And then the domain is asking what x values can we hit. And we can hit anything that is not an asymptote. Anything that is not at an asymptote. So same answer, but it does not equal. Okay, the range is a little bit harder to see in this one. Notice that the smallest y value it approaches is -infinity. And then it goes up to a y value of -1. And it actually hits -1, so I need a bracket for those. Then both of these skip some y values for a second. So I'm going to put u. Have you guys seen that symbol before?
Yeah.
Okay. You don't have to use that symbol. It just means union, which is a fancy math way to say and. I'm fine if you just put comma or say and or whatever. Then it hits y values from 1 to infinity. It actually hits 1, so it needs a bracket. It can never reach infinity, so it needs a parentheses. But again, if you know what range is asking for, the information is right there on the graph. -infinity to -1, and then 1 to infinity. Can't reach this one, you do reach this one, you do reach this one, you can't reach that one. Okay, let's do these in an opposite order. The secant graph, is it symmetric to the origin or the y-axis?
Origin.
Y, no.
Oh, y-axis.
It is y-axis.
Secant.
Sorry, maybe I said it backwards, I'm not sure. And because it has that type of symmetry, that means it's a even function. What type of symmetry does cosecant have?
Origin.
It has symmetry to the origin. If it was even, you should be able to flip this over the y-axis. This point would land here, and it doesn't. This whole parabola would be here if you flipped it over the y-axis. It's not there. So it certainly doesn't have y-axis symmetry, so it must have origin symmetry. And because it has symmetry to the origin, we know it's an odd function. That's a characteristic of all odd functions. Okay, these are definitely discontinuous because there's asymptotes all over the place. Lots of breaks in the graph. And then finally, the last piece, period. You're going to be tempted to just say pi, but if you just say pi, you either get a parabola up or a parabola down, but not both. To see the full pattern, a full cycle, you have to look at all of this, which is 2 pi. Same thing over here. To see a parabola up and a parabola down, to see the full cycle, you have to look at 2 pi of horizontal space. Okay, any immediate questions? Okay, so then what you need to do is you need to practice and see which of that has stuck and what parts didn't stick so you know what to review. So handout 31 has you graph the 4 new trig graphs, tangent, cotangent, secant, and cosecant. You should try those and then check your work with the notes. Don't just copy it over from the notes. This is really your one chance to practice it. because there's no other assignments that go with 4.6. And then 32, one column has where you can sketch each of the 6 trig functions, so the 4 new ones, plus sine and cosine, and then it asks in each column for all those characteristics. Where's the asymptotes? What's the domain? What's the range? Is it even or odd? What type of symmetry? Is it continuous or discontinuous? So looking at the sketch of the graphs on the left, you should try to answer those. And then check your work with the notes, because those exact questions are in the notes. And those exact questions will be on the quiz. The quiz is not next class, even though that this is a pretty short unit. Next class we will do about half of the class to make sure you don't have questions on this, and we'll do half of the test review day. And then the class after that we'll do the 4.6 quiz for half of it, and the other half will finish up the test review. So, you had a question, Jonathan? And again, just to be 100% clear, this is exactly the stuff we want you to know. You will need to graph tangent, cotangent, secant, cosecant. No amplitude changes, no phase shift changes, just graph those 4 and answer those type of characteristic questions. So those 31 and 32 are really your 2 chances to practice to make sure that you're ready for the quiz, even though it's not this next class. All right, any questions about that? All right, you really should finish up 31 and 32 for homework, but you guys also have a little over 15 minutes, so you could probably get half that done in class, honestly.